All right, I'm going to walk you through a two-dimensional and a three-dimensional vector problem. Okay, so this first one has three different forces. A 75 Newton force that's 60 degrees above the x-axis, a 30 Newton force that's 20 degrees above the negative x-axis, and then a 10 Newton force that's straight down. So we have the blue, the purple, and the red. And what we want to do is find the resultant of those three vectors. Graphically, what we're doing is we're going to add those tip to tail. So we would take, and it really wouldn't matter what we would start with, but let's start with the 75 Newton one. And it's going to do something like that. Then we're going to take the purple. We can add it there. And then we can add the red. And the prediction is, if my drawing is accurate, that the resultant, meaning the combination of all three of those, is this dotted line blue. So we're predicting that the blue is going to have a pretty steep angle. The magnitude is probably going to be a little bit less than the original blue. And the angle, like I said, is going to be a little bit more. It's the addition of all three of those. Okay, so how do we do this? Well, we have to break these three vectors down into their parts, meaning their components, and then add them together. The dotted blue is just the horizontal of this blue minus the horizontal of this blue. That's the horizontal of the resultant. And then we take this vertical plus this vertical minus this vertical to give us the vertical of the resultant. Okay, so how do we do that? Well, let's just do horizontal first. So we're looking in the horizontal direction, right, x hat, and we're going to break this one down and get 75 cosine of 60 minus 30 cosine of 20. And again, that's the blue minus the purple. We're going to subtract it because the purple is left. That's a negative x component. And we're going to type that out, and we're going to get 9.31. Okay, now let's look at the vertical pieces, the y direction. We have 75 sine of 60 plus 30 sine 20 minus 10. Again, both of these are positive because the blue and the purple vertical component is up. And then we're going to subtract 10, and there's no angle because this vector is completely down. Okay, you make that combination and you get 65.21. Okay, so if you want to find the resultant, we're just going to use the Pythagorean theorem. The Pythagorean theorem is basically saying that we know that the resultant is 9.31 that way and 65.21 up. And so we make that triangle. And so the Pythagorean theorem says that the magnitude is 9.31 squared plus 65.21 squared equals the magnitude, we'll call that r squared. And so r, which is the magnitude of the resultant, which we can symbolize like that, is 65.87. And then if we do inverse tangent, remember this angle, theta, tangent of theta is going to be the y over the x, y over x. So tangent of theta is 65.21 over 9.31. And if we do inverse tangent for theta, we get theta to equal 81.9 degrees, and we would say above x hat. And again, it follows exactly what we thought. The magnitude is 65, so the dotted line, the length of it is 65, which is a little less than the original 75. Right? This hurt us and this hurt us horizontally, and this angle, this is really 20 degrees, so it probably should have been a little more horizontal than it was in terms of the actual picture. And then the angle was a pretty steep angle because look, it's pretty much straight up. Okay, so that's a two-dimensional case, and it wouldn't really matter whether there were 3 vectors or 10 vectors. Break the vectors down into their pieces, combine the pieces, and then recombine again, this is the resultant, it's just in component form, 9.31 by 65.21, and then use the Pythagorean theorem and inverse tangent to find the magnitude and the angle. Okay, let's do a 3-dimensional case. Okay, so this is like some base, this is like the Coast Guard base at this origin here, and the helicopter is 1,200 meters away at 60 degrees, and you could say maybe 60 degrees north of east. And the helicopter is also 4,000 feet in the air, so it's a 3-dimensional case. It's so far east, so far north, and then it's got an elevation of 4,000. You are located here, 300 meters away, 20 degrees north of west. And the question is, what is this distance? We want to know that distance. And again, you got to go east, you got to go north, and you got to go up to get to the helicopter. So the first thing we want to do is just find the helicopter location. And again, the helicopter location is just breaking down those vectors. So this is 1200 times cosine of 60. 1200 cosine of 60 tells you horizontally where the helicopter is. 1200 sine 60 tells you vertically where it is. And then the elevation is just 4,000. So we can just put in 4,000. So that's the location. Okay, and if you type those in, you're going to get 600, comma, 1039, and 4,000. So that's the three-dimensional location of the helicopter. You are over here. So for you, you're going to be negative 300 cosine 20, 300 sine 20, and then you're on the water or you're on the ground, so you have no elevation. If you type that in, you're going to get negative 281, 102.6, and 0. Again, this is how far west and north you are and you're on the ground. The helicopter is east, north, and above the ground. Okay, so these are the locations. Now what we want to do is actually find the vector. Okay, and let's find the vector. We'll call this h and this y. So the vector hy. Okay, and the vector hy is starting at the helicopter. How would I get to you? And if you want to find the vector, we just need to take the final minus initial. So this is negative 281 minus 600 gives us that negative 881. 102 minus that gives us 936.4, and then negative 4,000. Oops, and that is a negative. And then negative 4,000. The negatives aren't going to really mean much, but in terms of the vector, it is saying if you're at the helicopter, we're going to make the arrow go this way, and what do you have to do? Well, you have to go west, which is why this is negative, south, which is why this is negative, and if you're at a 4,000 foot elevation, or meter elevation, you're going to have to go down, which is why this is negative. Okay, if you want the distance, meaning you're looking for the magnitude of that vector, well, that's just the three-dimensional Pythagorean theorem. So you're taking the square root of 881 squared plus 936.4 squared and 4,000. And you can see that I dropped the negative sign because when you square those pieces anyways, it's going to be positive. And you get a distance of 4201.54 meters. Okay, so in the two-dimensional case, you're going to break down the vectors, you're going to add the vectors together and get a horizontal and a vertical component, use Pythagorean theorem and inverse tangent to find an angle. In a three-dimensional case, I kind of added a step at the beginning where we actually had to find the helicopters in your location, and I made it 3D, so there's an elevation change. And then we're not really going to talk about the angle that we would have to fly. That's a little more difficult in the 3D case, but we would just talk about the distance between yourself and the helicopter, and then we found it. So hopefully this kind of helps you out in both the three-dimensional and two-dimensional case of how you can break down vectors using cosines and sines. And the one thing I will encourage you is that we kind of just assume that our x component is always going to be a cosine, and our y components are going to be sines. And again, if we draw the angle with respect to the horizontal, it doesn't matter what quadrant you're in, as long as we have this angle, cosine will be the adjacent and sine will be the opposite, and they'll correspond to both x and y.